Welcome to Thesen and Tresen, the still logistics talk. And this is your host for today, journalist and communication expert for logistical topics, Thilo Jörgl.
Hello and welcome everyone here from the 14th floor of the Hotel InterContinental in Berlin, and welcome to all of you streaming from your screens at home. Welcome to Thesen am Tresen, the still logistics talk. We've got a number of great guests with us here today. Let me introduce them. We've got from Frankfurt Erik Wirsing. He's the Vice President for Global Innovation at DB Schenker. Welcome, Mr. Wirsing. We've also got Andreas Höll. He is the Technical Industry Manager at the SICK business from Baden in Germany. Welcome to you as well. And from Hamburg, we've got Dr. Alice Kirchheim, the Professor for Technology of Logistics Systems at the Helmut Schmidt University in Hamburg.
Last but not least, Ansgar Bergmann.
And we've also got Mr. Ansgar Bergmann from Hamburg as well. He is Project Manager for Technology and Innovation at CTR Group. Welcome everyone. I can't wait to get started. We're talking about safety and research today. We have called it mostly cloudy, how cloud applications may prevent accidents in warehouses. Before we get started, would you like a drink? We've got iced tea or water for all of you if you'd like. 2 iced teas and 2 waters. Here we go.
Eistee einmal. Schön. So, hier noch ein Wässerchen. Bitte schön. Danke. So, ja. All
right, so as I said, we're talking about safety in warehouses, and I looked at the statistics a little bit. And in 2020, there were 30,000 accidents in warehouses happening in Germany, and 10 even had lethal consequences. That is a dire situation. On the other hand, of course, there is very many warehouses in Germany. And we've got a bunch of technology, sensors and systems that prevent accidents compared to the earlier times. And of course, we've got new technologies such as the cloud, such as 5G, which we are hoping will provide solutions for the future. We will take a look at those, and we will look at what their advantages are, the advantages of these new technologies, where are the limitations, and how can they be applied. Let's move on to our first thesis right away that Erik Wirsing has brought with him. As I said, you've worked for DB Schenker for over 20 years now in different areas and positions, and currently you are leading the innovation department since 2011 for Schenker Germany. Your thesis is that the safety situation in warehouses is challenging, but not everything that's feasible from a technological point of view makes sense or is affordable. What do you mean? Well, I think logistics is under huge pressure, unparalleled pressure really, and we're trying to automate things as quickly as we can. Technologically, there's a lot of opportunities, and if we look to other countries, we see that there's a plethora of things that we can do, but the question remains, how can we really implement them? It also depends, on the customers. Who are the employees on site? Sometimes there's a lot of temporary workers, and it's difficult to maintain training there. Support also varies from customer to customer. Also, affordability. Technologically, of course, there's a lot of things that are feasible. There are these pipe dreams of, warehouses void of people, really. And as an innovator, I think that's an exciting idea. But when it comes to the return on investment, of course, this is a difficult question. So we have to ask what technologies make sense in the warehouse warehouse and which technologies offer us options. So what can we also adapt from one warehouse to the next as well? These are a number of questions that we need to look into. Where can we support the humans working in the warehouses? And another topic that I think the pandemic has shown us is that technology has helped with preventative maintenance, for example, and with protecting employees. Technology has a lot of advantages when it comes to this, but we also have to involve the people who are supposed to work with this technology, because that should be our main goal, that technology supports us as people who work in warehouses. So technologies that are easily adaptable, you think is a good thing? Yes, definitely. So automated guided vehicles or robots, for example, those are all parts that we've seen become a lot more intelligent, a lot smarter over the last few years, and who can therefore support humans who run them. But there are, of course, also other examples where we clearly had to separate the robots working from the humans, because otherwise it would have been too dangerous, because the robots would, not be aware of the humans and then endanger them. So we have to look into these technologies. Anything that's basically structurally sound within a warehouse, that makes it more complicated. How can robots navigate these things, etc.? So there are challenges, clearly, when it comes to trying to, set up a business case and make sure that this is affordable and efficient. Would you agree with that, or would you think that Erik is more of an exception here with his arguments? Well, one thing we haven't heard is that it's not paying off, because usually these business cases start paying off after 2 to 3 years, because the staff cost is still and remains very high. So if we can reduce this by automating certain areas, of course that pays off. But still, humans remain the most valuable asset within a warehouse to this day. Yes, vehicles are fast, are agile, and we are trying to set them up in a way that they can become very fast. But still, if you have an efficient, a skilled driver, they add so much value, so much efficiency, that it still pays off more to have a driver there, a human there, because they can get an overview of the situation a lot more quickly. If things change, if the space changes, then a robot can. The prerequisite, of course, is that you have this staff, that you have this skilled staff on site. That's what I meant as well, because logistics is overwhelmed at the moment, and we are definitely very relevant to the system. We've seen this during the pandemic, but it's difficult to have these skilled workers on site still. It's difficult to motivate people to work in logistics, because there's a huge threshold now where people are very hesitant. It's stressful, it's high pressure, etc. So I agree with you when it comes to use cases. It does make sense to be able to reduce staff where we can, but that should not be our utmost priority. We should have more output, and we should have motivated employees who feel like they're supported by their company when it comes to cooperating with technology, with robots. But we have definitely got a lot of work to do still when it comes to training these employees to work with technology. There is a lot of technology on the street, in the warehouse, but the interfaces is still where it becomes difficult. How can we get products from the warehouse to the streets, etc.? Yes, definitely. Humans are still needed at these interfaces, at these bottlenecks, definitely, because they are just so much more flexible. So automating certain processes, that works. Usually that works really well. But loading goods from a warehouse onto trucks, that can vary, because the trucks all look different, for example. So that's where we need humans and their flexibility. And we're working on solutions, of course, as an industry, but there are challenges. Well, Erik, your thesis sounds kind of like something, yes, that's something we want to take off. We want a dark factories. But it's just not a fact of life, is it? And I've noticed this with my students as well, who wonder why humans still work in warehouses. And then I have to tell them, no, this is the standard, you know. This is what we will keep needing for a number of years. Yes, I think that's really interesting, what the perception is and what reality looks like. We've had this impulse that you've given us when you said, if we were to be fully automated, we wouldn't have to take care of safety, but automation is not going to work. So there's a bit of tension here, yeah? The return on investment plays a role here, because we cannot automate everything because we still need humans, but using humans is often more expensive. So how do you strike a balance here? How can you make this all work in the grand scheme of things? Yes, I agree. And just like you said, you know, humans, because of their flexibility, they just cannot be replaced. Of course, if, you know, all the packages, all the pallets looked exactly the same, maybe robots could handle it. But all these pallets look different, and sometimes it's not even pallets. Sometimes it's big barrels, for example. Sometimes it's large parts, etc. So of course, humans cannot really be replaced there. Though, as you said, in some parts it's starting to work. But yes, I mean, if you just take a look at our hands, I mean, this is something that you simply cannot replace with technology. They are so flexible. So as a scientist, I do think that it will take decades until we are able to replace that. And until then, we're going to need humans who can do these tasks, who can perform these tasks. Definitely, as a manufacturer, I agree with you. Hands are very, very useful. But I do think that you're right when you said that we need to separate between the functions of safety technology and how they are relevant to automation, and in what way they are relevant to humans. Where is the added value here? Should we only invest in safety systems that are only for humans, which of course is absolutely necessary, is essential, but it may also be a question to say, how much do we need to invest in safety, and what areas of it can we replace with technology? But what I would like to see is the politics of small steps, you know. Yes, of course, it would be great if we could fully automate warehouses, but if we wait until we're able to do this, we are losing a lot of experience that we could gain. We do need to learn. We need to look at the processes and look at what they should look like, how they should work. And this is our clear statement and our desire as well, to say, yes, of course we're not able to do it all yet, but do challenge us. Let's try to do partial automation, for example, because this is how we learn. This is how we streamline our processes, how we fine-tune it all. Let me just get back to Andreas as well and his thesis. You've been working since 2001 for Waldkirch and are now responsible for the huge projects in the R&D departments. And your thesis is that technology in the area of safety is still not flexible enough. What do you mean by this? Well, basically, it's all been said already by you, among others, because, I mean, I do have to clarify, not flexible enough. What I mean is, it is flexible within the boundaries that it can cover, because we're all coming from that angle where we're trying to protect humans, but the technology is sort of like building blocks. And if we go about this the right way, it seems simple to be flexible, to say, you know, replace this building block with another, put this on top of the other. But it's not a pretty picture. It's not very flexible because we can only add to the building block. It's kind of like building Legos. But only having very basic parts, you know. So the structure, you know, you can build any structure, but it's difficult, you know. Is it pretty? Is it really working well? Is it really adapted to what we're trying to do in this process? So this is where we have to rethink safety technologies. Of course, this is, what we live off of. It's important to have these building blocks and to have a certain flexibility, but this is where added values come in. This is where the ROI comes in. We need to look at the processes that we have already and then realize that we can't just, add safety technology on top of them, but that we have to be a bit more creative. We need to set new standards. And the point is, because these solutions have to be so individual, it's hard to get off-the-shelf products when it comes to safety technology. And that's a challenge that's often quite expensive as well. When we look at the AGV, for example, that's a very clear building block. And it shows us that we always have to take care of the question in which context we can use AGV technology, for example. So you have to see the bigger picture. We have to approach it from all angles and then make sure that the added value is maintained. So let me clarify what you mean here. You see safety technology in a warehouse, for example, that we look at the warehouse and we always consider safety technology from day one. Is that right? Well, what I mean is, how do I put this? It's difficult with logistics, of course, but quite often what we see is that at the end of the project, when it's almost completed, people remember, oh wait, did we forget something? Oh, right, there are, hazardous zones. So they are never considered from the very beginning. They're not taken into account. It's just something that we notice when we're almost done with the project. So, and I think we could improve this. Yeah, if we're included from day one, we can point people toward these processes. But isn't that where software comes in? Software is, the name already is telling, because it's soft, it can be adapted easily. It makes things more flexible. So maybe it's the right software that we need. We have sensors that, yes, are standardized still, but their areas of application are so easily adaptable because they can be configured with software, right? Of course, that's true, but then we also have certain software certificates that need to apply, and the operators have to be able to work with them, right? But what I mean is, if we consider this, if we consider which software we need to reach these or those goals from the very beginning, then we can be a lot more efficient. Then we can be more transparent in warehouses as well. Because yes, we might have sensors everywhere, and the sensors monitor the whole situation in the warehouse, right? So that's a lot of information we can work with. Well, when it comes to certifications and standardizations, that's a very German thing, isn't it? In Asia, they just go and test the first 80%, and then the last 20% of a new software they will just sort of program on the fly. And that works too in a way, but of course in warehouses and in businesses that would never be allowed in Germany. So as Germans, I think we have to also be aware of the fact that we're also limited by our own standards and regulations a little bit. So sometimes I think we wish for more relaxation there, because like you said, we need to gain this experience. Most of the patents in the world come from Germany, and then we don't do anything with them, and that's a pity, I think. I actually hadn't considered this approach at the beginning, but if you imagine it, to have a whole safety concept right from the very beginning and don't have to add them like building blocks afterwards, then I think that might also make financial sense, right? Because then you don't have to have the sensors just like Big Brother added afterwards. That might also make people a bit critical if they see it this way. But if we have it as part of the whole project from the beginning, people might also be more open to using it, right? Yes, exactly. And we will be able to create more individual solutions because of that as well. if we're involved from the beginning, I think it will pay off. And it is the added value that I think is a big argument here. It's a complete solution. So I think you were saying that you would like to see a flexible solution. But still, I think the building blocks image remains, but just that you can add your building block from the very beginning, right? Yes, definitely. And if programmers are involved from the beginning, then they don't find their limits quite so quickly because they are always involved in the process. They are very flexible. And then they can also go to the next customer and say, so this is what we did here, and we can just easily adapt it to your system. Because if you go from one use case to the next and always start from scratch, then it's really expensive and it's very inflexible. Would you consider digital twins for this? You might know this from research as well. Digital twins are a hot topic at the moment because then you can get started with this module. You have this standardized process and it works, and you can then simulate and then adapt it to new customers. That's basically what a digital twin is. It allows us to have digital simulations. Yes, definitely, and it helps us as logistics businessmen to look at what's possible in the individual warehouses, and we can be very flexible with the IT systems that we work with. So if we're all more open among ourselves, I think digital twins make a lot of sense. We can look at all the individual processes in a simulation, and then I can use the building block system and see how it all works. But you said, because we only have the basic building blocks, it's difficult if we need to work with a very tiny system. So yeah, it looks like we're all experts at Lego here, but let's move on to the next topic.
Alice Kirchheim, you are a professor and you work in many fields regarding technologies, and your thesis is the economical use of 5G in intralogistics is still a matter for the future. So what do you mean by that? Well, I know that I am the kind of person who deals with 5G and 5G campus networks all day. So I can say that using 5G is mega interesting for businesses because you can get a frequency range reserved and run it as a private user. And that is a different radio range than the public range. And if you were able to run such a network on your own premises, you could actually configure it yourself and use it. You could have AGVs, or you could have surveillance, or maybe surveillance is the wrong word. You could use it for video monitoring. And a lot has changed in the past 2 years, and it just popped up all around the scientific community. As at today, in 2021, 148 applications for licenses arrived at the German Federal Licensing Authority, and I suppose SICK already is applied for one, and research institutions like our university. And there are 50 companies that have such a license, and those who have it complain that participants who are to use it need their licenses too. And they also need the devices, which are not tiny handy tools. So we haven't really come so far. Public opinion believes that we've come quite far, but 5G campus networks will need another few years to be run economically. And that's important to know for users. So if that were available nationwide, there would be thousands of use cases that would make it meaningful, because you could also have backups, etc. And in navigation, Wi-Fi and other technologies are enough. But for example, for autonomous driving, you would need 5G because you need the chance to step in real time, but Germany is lagging behind. Well, I would agree as at today. I can only support what you said about what is available and what is not. But it is an interesting approach, because where do all these mobile telephony people come from? They come from B2C, and I keep following their development, because you need to understand these worlds. What does it mean? When we talk about automation, we finally find that they start understanding what we mean by that. And very often, and that's my perception, that we need to think about the application of 5G. What is it? Actually, you need a lot of applications that are tied into it, including operator pins, etc., etc. And at some point, it's not a single component that is expensive. But there's more than one solution. Well, the 5G campus, have you tried it? Well, I don't like contradicting, and I think that it isn't even so expensive. We're going to have a 5G campus application network soon, one at each location. But in our business, 5G is something that we definitely need. It's going to solve a lot of problems, and we can see the limits of Wi-Fi now already. We aren't users, we aren't consumers. And I can remember the first telecom contracts that said 90 euro per month for 5G. Nobody is willing to pay that. So far, it's been a problem of few providers, because those who are in communication also are in the industrial area, and the Federal Ministry of Economics is actually funding campus networks, radio access networks, RANs, and you can actually buy into Microsoft, or you can get an open source tool which costs nothing or nearly nothing. So when we enter 5G, it's more virtualized. I'm not going to name any names here. There are various manufacturers who actually shape their prices at the moment, but there will be times when 5G can be used on any computer with any aerial, and that's where we are heading. The Campus S project is precisely about finding out what the needs of industry is and what the open standard has to cover, and that will take us to lower prices, clearly lower prices, and it will also get us away from all the providers, the big mobile telephony providers, because that's the important thing about the Open RAN and campus systems. It will enable smaller businesses to run such networks, and that's a great opportunity for German industry. I think it's really a great chance of coming up with a solution that will make 5G campus networks materialize. The standard is that we all have our own apartments, our own small businesses, and we go to the shop and we get our devices, and we use a small provider of our choice. And that should also be possible for the industry. It also creates competition, which means that there's not just 3 providers, but 30, and reasonable prices. due to that. Let me come back to the issue of safety and security, because at that point you could actually replace hardwired safety systems with wireless safety systems, and yeah, that's precisely the issue. You don't want complex infrastructure. We're actually looking at the whole matter from the point of view of safety, because we found that wireless networks were too slow in responding, and actually the emergency stop works, but stopping an LGV or working on a machine, the response times were just too long. And we found that with the existing stable 5G network within the factory, where data will stay, they have to stay in the campus network. I can do that, and it means that I've come up with a use case that will take me through a lot of steps. Previously, I didn't have to think about stopping an AGV from the outside, because the network was too slow anyway. But now I know I have a stable network. I'm back to square one, but now I can actually take the steps to link it all up. Well, the standards and the guidelines are still being prepared, and there is no safety standard at the moment. Well, I don't actually need it, because transmission media, as at today, for safe control systems, control to control, for example, they actually exclude the medium. The medium is not defined. It can be wireless, it can be copper hardwired, so you don't need any extra standardization. And you can scale it up. You don't have any requirements as to the medium. So I don't have to actually wait for any standards or developments. I can actually get started. There are, of course, a few points that need to be raised, because flexibility is not entirely covered by technology, but I can actually get started. I would like to come back to something that we mentioned a couple of times, and it has to do with data analysis and Ansgar's thesis, communication of systems, etc., communication at your end in the company, and data protection. You say that data protection provisions are a killer, especially in Germany. Face recognition is not a problem in Asia, but things are different in Germany. You don't really need my thesis for that. It's been addressed before. The systems that came to the market first were far removed from what we have today, but still we had discussions with the Works Council, and many things failed because of that. Systems were not installed in spite of the fact that they would have added value back then. Today we are talking about something totally different. We mentioned facial recognition. AI doesn't work without training data, so I actually store biometric data of employees on a computer and think of all the provisions that I have to stick to so it doesn't go wrong. And when I do that, I actually have to argue that the machines can see everybody, and features that could be personalized, and that would be possible using biometric data, would actually be blocked, because people would say, well, but then you can follow where I'm going. But what I say is we want to be autonomous and we need these data. You cannot replace the hands, you cannot replace the eyes or the brain. So I have to get to a point where I can get parted. The brain tells me, okay, I can see this, but I don't know whether it's stored. So we still have to store data because we need the training data and because that's the way the systems works. And it's still difficult. It is feasible for research purposes, but to actually roll it out, saying I have access control that just works on the basis of facial recognition, and that helps us use high performance sensors that can cover lots of functions, that is still difficult. The big benefit, even though you don't like that, the big benefit is that we would like to work with fewer sensors. I know that you want to sell more. Today, you actually click on terms and conditions on the internet without reading them, and you download software. And it never happens that way in a company. Whenever council involved, that might be our problem, because there is much more awareness in Europe than in the United States. People think about whether they are allowed to store, to share, to show something. Well, I think that the data protection regulation is good, and the policies of that type are good. What you are saying is that the Works Council is mingling, or would you say that everything ought to be transparent? Well, no, it's about handling and about managing. First of all, you need to talk about it, but actually that has oversensitized people, and they think about things in bigger contexts. All I'm interested in is training AI. I'm not interested in whether a person walked from A to B. I'm not interested in the person. And at the end of the day, these systems only work with a broad scope of data. One thing I would be interested in, the practitioner's view in DB Schenker. What about communication that you could try out in Asia that is not possible in Europe? Well, there is technology that we can test in some countries and we can't test in other countries, and we actually hope that the countries where we can't test can see how good this is and how safe this is. So we're doing lobbying, and the question arises, of course, which data am I using and how am I processing them? It might be good to know that Germany has very strict standards, because something that comes from Germany must be super safe. But yeah, there are downsides. With COVID and the pandemic, actually we had sensors that showed employees the distance to others, and they made sounds. And what we told our employees just needed to know that this was for contact tracing, because if you know how close you got to people, you don't have to send home all the workers of an entire shift, but have to restrict that. And if the Works Council is informed, they will usually not put up any resistance. It's just a matter of communication. I think that we can be a little more relaxed in Germany. I do agree with you. Now, our last topic on the list, data security. Without data security, you can't really run a business. Yes, absolutely. In the past few years, we were attacked ever so often, not just by Trojans or we actually saw attacks with our company logo. And if you're an international company, you have to be very, very careful. If you're not well established in terms of cybersecurity, you will not be able to run the business, because everything is interlinked, everything works through the internet, and you're always between the devil and the deep blue sea if you work in logistics, because of course the cyber attack might jump over from a customer to your own network. We have these hacker attacks, but we would not be able to work without IT, because e-commerce would be completely down and trucks would not run, airplanes wouldn't take off. And that's the point where people realize that logistics are vital. That is a great concluding remark. Unfortunately, we're actually at the end of the time budget that we have. Thank you very much for all the great contributions. Thank you to those who tuned in. These sessions can also be watched on www.still.de. Thank you for everybody, and we'll meet again at the bar. Thank you.